Hello friends, in this video we are going to talk about our Leetcode problem of the day, and our problem is basically find the minimum and maximum number of nodes between the critical points. Basically, a critical point is a linked list is okay. It is defined as either a local maxima or a local minima. A node is a local maxima. Okay, a node is a local maxima if the current node is strictly greater than the previous node and the next node. Okay, so basically this is the head we have been given. So basically this is the head of a node given us to us. Okay, and the values are 1, 3, 2. This is the previous node and this is the next node. Okay, and it is the current node and this is the current node. If the node which is the current node which is in between the two nodes is greater than the left value, it is greater than the left value and also the right value. Means if yes, means if our P is less than C, also our P is what it is yes. If our P is less than C, also the N is less than C. N is less than C. Okay. If it is so, then our node is called a local maxima. It is called local maxima. Okay. And then read further. A node is called a local minima if the current node has a value strictly smaller than the previous node and the next node. Okay, this was the local maxima. Now let's see the local minima. This is the node given to us. This is basically 3, 4, 2. This is the 3 is the previous node and the 4 is the next node. The left one is the previous node and the right one is the next node. But the center node present in the center is the current node. Okay, if the current node value is less than the previous node, also the current node value is less than the next node, then the node is considered to be it is considered to be what? It is called local minima. It is called local minima. Okay, now let's read further. Note that a node can only be local maxima or local minima if there exists both previous node and the next node. Okay, means there must be at least three nodes present. There must be at least three nodes be there which are previous, current and next. Okay, at least three nodes be there. A given a linked list head return an array of len 2 containing minimum distance and maximum distance, where minimum distance is the minimum distance between any two distinct critical points and maximum distance is the maximum distance between any two distinct critical points. If there are fewer than two critical points, return -1 of -1. Okay. First of all, let's see an example. It would be much better than yes. So we have been given a head here. So in this head, let's see the a local maxima. Let's see for the local maxima here. As you can first your P, C, and N. This is our P, this is our C, and this is our N. So it is there. As you can see that our current is less than the previous, but it is greater than the next. So the condition is invalid. So our PCN We'll move on to the next part. Wait a minute. Our PCN will move on to the next part. Okay, as you can see here, our PCN will go on to the next part. Now, you can see that the one that the our current is 1 now. Our one current is less than the previous one, also it is less than the next one. So this is our local minima. We have got here our local minima. Okay, as you can see here, we have got our local minima. Then move forward, again moving forward. Then our pointer will again move on to the next part. Okay, our pointer will move on to here. So now it will see that if our current is now 2, if our current is greater than the previous one, but it is less than the next one. Okay, so the condition holds here invalid. Okay, the condition holds here invalid. Now we will go on to the next part. Our pointer will again move forward. Yes, our pointer will again move forward here. It will go on here. Okay, now as you can see that our current is now 5. Our 5 is less greater than the previous one. Also it is greater than the previous one. Also it is greater than the next one. Okay, so we have got here our local maxima. As you can see that we have got our local maxima. Again now we will move forward. Now we will move forward here. Okay, now we are able to see that our current is what 1. Our current is 1. So as it is less than the previous value, okay, as it is less than the previous value, also it is less than the next value. So this is our next local minima. Okay, so we have got two local minimas and one local maxima. So what is the concept of this minimum distance and maximum distance? Okay, minimum distance and maximum distance. Minimum distance is the distance between any two distinct critical points, and maximum distance is the maximum distance between any two critical points. Okay, so now let's do the indexing. Here, there we go. Yes, as we are able to see that we have got our local maximum and local minima. So now let's move forward. We are going to see that what are the respective index. In linked list, the indexing we start from 1 to from 1. Okay, we don't start from 0 in linked list. So the index is what 1. Basically, it's 1, 2, 3, 4, 5, 6 and 7. And our local minima is here, our local maxima is here, and again our local minima is here. Just wait a minute. I don't know why my laptop is giving a problem to me. Hold on for a minute. Yes, there we go. And this is our local minima. Okay, this we have got our local minima here. So now we will subtract the indexes from each other. First of all, we will subtract the find the minimum distance. Okay, as you can see here, the indexing, as you can see the indexing here, the distance is between is where what 2 here. Okay, the distance between in the index 5 and index 3 is what 2. The also the distance between the index 5 and 6 is what it is 1. Okay, and also you can see that the distance between the index 6 and 3 is what it is 3. So you can see that the minimum distance here it is what minimum distance here is 1. Okay, so we have got our minimum distance. Okay, this will be our minimum distance. And now you can see that the maximum distance. Maximum distance must be the distance of the end point minus distance of the first point. Okay, it will be the distance of the end point minus distance of the first point. So you will subtract the index 6 minus 3. Index 6 minus 3 you can do. So it will give us 3. 3 as the answer. 6 minus 3. So our answer will be what? 1 comma 3. So this will be our answer. Okay. So in this method we have used PCN. P is our previous, C is our current, and N is our next. Okay. So basically, okay. So basically our P is at 5 as you can see. Our C is at 3 and our N is at 1. Okay. So this is our PCN. So our PCN will be go on incrementing and incrementing node by node. Okay. It will go on incrementing and incrementing. This will be our P, this will be our C, and this will be our N. This is basically our N. Okay, this is our PCN, and it goes on incrementing and incrementing, being node by node. As you can see, first it goes to here, then it goes to here, then it goes to here. Okay, so it goes on incrementing and incrementing. So basically, as you can see, that our P is equals to what? Head. Okay, our P is equals to head. Our C is equals to what? Head dot next. And our N equals to what? Head dot next dot next. Okay, as you can see, this is our red one, P, C, and N. Okay, respectively. Now we are going to see our upper PCN. What are their values? So our P is, as you can see here, as you can see here. Okay, our P is pointing towards what? Our P is pointing towards the C here. As you can see, our P is pointing towards the C, and our C is pointing towards the N. Okay, so basically, our next will be what? Our P is equals to C node by node, and then our C equals to what? C equals to N. So N is basically C equals to N. So N, and then N is equals to N dot next. Okay, so this will be our approach. Okay, so now let's code for it. First of all, I will be solving the problem in Python. Then we will solve the question in C++ also. Okay. First, we will define our heads. Okay. First of all, we will define our head. If not head, okay. If not head or not head dot next means there must be at least three values. So this is our or not head dot next. Okay. So these are the three values. If these are not there, so we will return minus one comma minus one. Okay. Then we will create a list of what? List of result means result, or we can say critical points. Critical point equals to list. Okay, then we will initialize our current and next previous, current, and next. As previous as head, current as head dot next. As you can see here, as you can see here, okay, head dot next, and next equals to head dot next. Okay, and we will initialize our index as one, I as our one. Okay, or you can index as our one. Okay, then we will run a while loop. We will iterate through the while loop, while n. Okay, now we will check if our value of c, if c dot val is greater than the p dot val. Okay, and if our c dot val is greater than the n dot val. This is for the local maxima. As you know, this is for the local maximum. That does current value is greater than the previous and next both. And now we will check for local minima. Means c dot val is less than p dot val, and c dot val is less than the n dot val. Okay. So if it is so, now we will append the index to the critical point. We'll attend the index to the critical point array. Critical point append. Append what? Append the index, respective index. Okay. Yes. So as now we have appended our index. Now what we will do? Now we will change change the pointer, means the P, C and N, to what our P is now C. Okay, our P is now C, and then our C is what? Our C is N. N is basically, wait a minute. Yes, our N is basically what? N dot next. Okay, as you know, then we will increment our index by 1. We are incrementing our index by 1 means we are going index by index. Okay, and checking. Then we will check if the length of the critical value, if the length of the critical value is less than 2, we will return -1 comma -1. If the length, some indentation, yes, if the length of our critical value, means the critical point, is less than 2. If it is less than 2, then what? Then we will return -1 comma -1. Okay, we will return -1 comma -1. Then we will initialize our minimum distance. Minimum distance as float of infinity. We have initialized as the float of infinity or minimum distance, and then we will check for the minimum distance for I in range 1 to length of our critical point, 1 to length of our critical point. Okay, then we will move forward. Yes, 1 to length of our critical point. We will check the minimum distance. Minimum distance equals to what? Minimum of minimum distance, comma, critical points of I minus critical points of I minus 1. Means, please focus on the whiteboard. Means, as we have got our critical point here, also we have got our critical point as here. Okay, at 1, as you are able to see. And our next critical point is what? Our next critical point is here. Okay, so we will go on subtracting in each index from other index. Means the index 5 minus index 3, the index 6 minus 3, and then index what? 5 minus 3 and 6 minus 3. Yes. So we will find the minimum distance. Okay, the minimum of the which distance we are getting. So critical point of I minus critical point of I minus 1. Okay, critical point of I minus critical point of I minus 1. And then at last we will return the, sorry, I have not checked for maximum distance. Maximum distance equals to what? It is equals to the last index, as you can see, the last index minus first index of the what? critical point of -1. Critical point of -1 is used for checking the last index. -1 denotes the last index of the array. -2 denotes the last second index. -3 denotes the last third index. In this way, the indexing goes on. Minus the critical points of 0. Critical points of 0. 0 means the first index. Okay, the array contains three indexes. The index 3, 5, and 3, 5, and 7. 3, 5, and 6. Sorry, 3, 5, and 6. So it will go on checking. Then we will return what? We will return the simple one, the minimum distance, comma maximum distance. Okay. Now let's try to run the code. Yeah, it's giving the correct output. Let's try to submit it. Yeah, as you can see that our code is being accepted here. Okay, our code is being accepted here. So now let's see the code by let's see the code of C++. Okay, yes. Now let's see the C++ code. C++. Okay, so first of all, now let's see. In Python code, as you are able to see in our Python code, we are checking that if not head, if the three elements are not present, we will return -1 comma -1. In Python, we are checking. The same we will do in C++. We will check, first of all, if, explanation mark, if not head, or if not head, not next. Okay, what happened? Yes, or if not head dot next. If it is, if the three elements are not present, we will return just -1 comma -1. Okay, a semicolon here. Yes. Then we will initialize the previous, current, and next to our linked list. Okay, list node previous equals to what? Head. Current equals to head next. Then next equals to what? Head next of next. Okay, we have initialized our P, C, and N. Now we will initialize our index. Our index as 1. Int index equals to what? 1. Then we will initialize our critical point. the list of our critical point. Okay. So in this in C++ we call it as vector. Just the logic is simple and nothing else. Int. Int what? Int critical point. Int critical point here. Int critical point. Okay. Now, now what we have to do? We have completed this part of our code in both C++ and Python. As you are able to see, this part of code we have completed. Now we will run a while loop. We will run what? We will run a while loop. While the next node. Sorry. Yes. Now we will check that our let's make it. Yeah. If our C dot if the value of our C is greater than the value of the P, means the current is greater than the previous also, and ampersand also the value of current is greater than the value of the next, then it is called local maxima. If the value of the current is less than the value of the previous, also if the value of the current is also greater than the value of the next, means it is smaller. I'm sorry, if the value of the current is smaller than the value of the previous, also it is smaller than the value of the next, then we will append, means we will put the index in the what in the list called critical points. Okay. So in C++ there is we call pushback. We use pushback in C++. Okay. Same in Python we call it as append. Okay. So now as we will move forward, we will now initialize the P, C and N to the new values. Okay. As you can see in the Python code, we will initialize it the new values. Our P will be equals to C, our C will be equals to N, and our N will be equals to N dot next. C will be equals to N dot next. Okay. And we will increment our index by 1. Index plus plus. Okay. Wait a minute. Yeah. So where we were incrementing the index here. As you can see, we are incrementing our index. Okay. Then we will run a if. We will check that if the critical point, if the length of our critical point is less than 2, we will return -1 comma -1. Okay. Now let's see. Yes. Now we will check if our Yes. Now we will check if our critical point is less than 2, means critical points what size of the critical point. If the size of the critical point is less than 2, in Python we use length. If the length of the critical point, okay, but in Python means but in C++ what we use size function. If the size is less than 2, we'll return -1 comma -1. Okay, if the critical point of size less than equals to 1, we will return -1 comma -1. Yes. Now we'll move forward. We will check for the minimum distance. We will initialize the minimum distance as the int max. It is infinity in the C++, but it is float of INF in Python. Okay, just a bit difference and nothing else. Minimum distance equals to what? Int max, int max. Yes. Now we will check for the minimum distance. Okay, we'll check for the minimum distance. So for that we will run a for loop. For yes, we will check for a for loop for int of j equals to what 1. In Python, as you can see here, we have run the for loop from 1 to length of the critical point. So we'll run the for loop in C++ from 1 to the length of the critical point, means the size of the critical point. Critical point dot size, and then we will go on incrementing our array j plus plus. We will increment, okay, as we will iterate. Now we will check the minimum distance. Okay, minimum distance equals to std of min. Okay, minimum value, min distance comma critical points of I minus critical points of I minus 1. So I am copying from the Python code. It's just simple and same. Yes, critical points of I minus critical points of I minus 1. Okay, as you can see here. Yes. So now we will check for maximum distance. Okay, we will initialize int max distance equals to what? Critical points of critical point of what? Critical points dot back. Back means the last index of the list. Back means the last index of the list minus critical point of front. Okay, front means the first index. Front means the first index here. Okay, so we are subtracting each other, and now at last we will return the values. We will return minimum distance comma maximum distance. So this is the C++ code. Let's try to run. Hey guys, in Fine. Here is a compilation error. That was only I was trying to say you. What expected, uh, what it's expecting a semicolon. It is expecting a semicolon here after declaration. Error expected member name or semicolon. Which member name? It's asking about which member name. I'm not getting it. Hmm, yeah, after it's giving that line number 32 if statement. Critical pointer size less than 2. Okay, okay. Yes, as you can see that I have initialized the wrong thing. Okay, now I think it must run properly. Compilation error after declaration of specifiers, which expected member name or semicolon after declaration of specifiers if critical point dot size. I don't know what it's talking about. Let's read the whole code. The vector while loop I have run it properly. Vector in critical point. Let's make it more indented. Okay, then critical point, not size, is less than 2. We'll initialize the int minimum distance equals to int max. Okay, then I have run a for loop. For loop has done it. Yes. Then I have chosen the int maximum and then returning the value. Now let's try to run it. What the fuck is going on here? It's why it's giving this kinds of error. I'm not understanding. Expect. Oh my god. There was just a problem of a simple space. Okay. There was just a problem of a simple space. Compilation error. Expected member name or After declaration of specifiers. Bro, what the fuck? I'm not getting it. Let's try to chat GPT the code. Fixed error and okay, okay. I have used and here. My and in place of and here, yeah, I have to use or. Okay, what it's talking about the code fixed logical error and instead of credited critical or pointed in critical point corrected. Bro, I'm not understanding that what they have changed in this is what they have changed here. I don't know. Let's copy the code and run it. What's happening to this code? I don't know. See, struct list node. Again, there's an error, struct list node. Let's try to run it. My goodness, it has been run properly. Okay. As you can see that it's faster than the 82.68%. Means its runtime is better. Okay. So guys, this was the Python code here and this is the Python code. Wait a minute. Wait a minute. Critical point. I have forgot here one thing. I have just forgot here one thing. If the critical point, if the length of the critical point is less than 2, if it is less than 2, we will return minus 2. Invalid. Yes. Now let's try to run it. Invalid syntax critical point. See guys, it's giving again an error. Now let's try to run it. Yeah, it's running properly, thank God. So basically this is our Python code. Okay, and this was our C++ code. You can see it properly. Yeah, this was our C++ code. You can see it properly, and that was my Python code. Okay. So thank you guys. If you have any of the doubt, you can ask me in the comment section. Thank you.